The session today is for middle school students, so 6th to 8th grade. Therefore, the game I'm going to demonstrate today is a bit more complex than the one I showed in the previous session. This game was developed by me and my son in just the last few days. It's called Asteroid Field. It is practically a scrolling game, a concept similar with a Flappy Bird classic game. In Flappy Bird, the goal was to keep an object from falling to the ground or touching certain objects. We created our own game with our new additions, and we adapted this scrolling game concept. The goal in our game is to keep the spaceship from falling and from hitting the asteroid belt. So the player will navigate through the asteroid belt and into the next level of the game. It is a multi-level game in the end. And you earn a point every time the spaceship goes through the asteroid belt safely. And you need to try to survive as long as possible. You see there is a score. I get a point every time I pass one level of the asteroids. Alright, so this is just a bit of the game for now. It is a multi-level game. This is a game in its full form. We'll reconstruct the game from scratch today, so to speak. So we'll start from zero and we'll build up from the base. So we'll start with the simple form of the game that has to be functional to demonstrate just basic game mechanics. And then we'll start adding the extended features. The simple form of the game practically has to allow us to navigate the spaceship through the asteroid belt safely, just as I showed to you, and to survive as long as possible. That will be the first thing we need to show in the game today. And then the extended features that we added to the game and we'll start adding in our reconstruction will be the score, the timer. The score, you can see it here. Every time we go through the belt safely, we get a point. This timer is a stopwatch, so we'll have a stopwatch to record how many seconds we survive in the game. The levels, we have 4 levels in the game that continue, they roll on randomly, and there is a degree of difficulty added with passing to the next level. What actually happens, we have a cross time here. What this cross time is, it shows in how many seconds one level of the asteroid belt reaches the other side from right to the left, because that's a number of seconds. When we go to the next level, let's try to get to the next level this time. When the score turns 5, we go through to the next level. So the backdrop changes. We have a sound that is practically called teleport. I thought it was nice. And the cross time decreases, which means asteroid belt moves faster. It glides across the screen a bit faster than at the beginning. With every level, it's going to be faster, and the cross time decreases with 0.25 seconds. Okay. We are receiving the message here from our AI assistant, Iris. We are going through to the next level. And we set the backdrops that show the next level to be picked randomly by the game. There are 4 backdrops. We did not set the order. They're just picked randomly, so they might repeat the way they are chosen by the system. We decrease the cross time to 9.5. I survived over 118 seconds for now. I'll keep going until I'm being killed by an asteroid. So this is a concept of the game. It is called a scrolling game because this enemy, we call it an enemy in the game, the asteroid belt, scrolls across or it glides, and we'll learn as we build how we build this feature in the game. I believe I can let it go now. All right, I'm getting a break. I will let it stop now. There is a menu, as you could see. The menu allows us to give instructions and to have a key to start. So the button doesn't function as a button, it just gives instruction which key to use to start the game. And we also including the subtitles. This is a sort of AI message that gives a communication with the captain of the ship. And of course, we have a restart button. It's going to work. I can just restart the game just pressing a button. And these are practically all the extended features we added to the game, and it works pretty well. We'll start building the game now. So we create a new project. I'm going to title it the simple form of it in the beginning. The first thing we do is to choose a backdrops. I like to choose a backdrop in the space category. I start with nebula, and then I'm going to choose another 3 backdrops to have them for later when we work on the levels. So the next one was galaxy. Stars. Whatever else. Neon tunnel. So now we can see all the backdrops here. Starting with nebula, galaxy, stars, and neon tunnel. The first one for the menu will be nebula. We need to create 2 sprites. One of them will be the spaceship for the player to control, and one will be the asteroid belt the spaceship needs to avoid. We can choose the rocket ship from here. Here it is. It is slightly big, and I'm going to reduce it to 30% size. All right, this is good. The rocket ship has several costumes, as you can see here. So there will be a movement going on as we change the costumes. And for the asteroid belt, we'll create sprite on our own, and that will have several costumes as well. We'll upload our own picture to create the first costume. This will be a rock, practically, then that will be the basis of the belt, or the asteroid belt. We resize it to make it smaller. And we create the first costume. We align 3 of these rocks, and there will be a space in between. This is how one of the costumes looks like. Then we can duplicate the first costumes, and we just change the position of one of the stones. Therefore, each of the costumes will have a space somewhere, and through that space we'll be able to navigate the spaceship. And when we start changing the costumes, they will come randomly on the screen. We'll program this sprite to allow a random order of the costume. We place it on the screen. We need to find the start location. So we start right at the very right end of the screen. So the first line of code we are writing is to just position the sprite. That will be on the point 200 on the x-axis and 0 on the y-axis. We'll make the rocket ship show on the screen as well. Again, when the green flag is clicked, that shows the beginning of the game. Show. I'll code the rocket ship sprite first. So first things first, the look of. When it shows on the screen, we want it to appear with the first costume. Switch costume to rocket ship A, the first costume. And then we want to start changing those costumes to show some movement. So let's first wait for 1 second before we start changing costume. And we need a forever loop. We go back in looks, change to next costume, and wait for a little tiny bit in between the costumes. So this will be just 0.1 seconds. So what this does is just to, spin around and show some movement. The next thing we'll do will be to position it on the screen. So again, I start with the event when the green flag is clicked, which means the position where it appears on the screen when we start the game. Go to position is going to be on the other side of the screen, on the left side of the screen. So that will be minus 175 I choose on the x-axis and 0 on the y. And we position the rocket. The next thing we'll do is to cause this rocket sprite to constantly fall down. So first of all, let's wait again for, let's say, 2 seconds before we start falling down. We add again a forever loop. Forever is that it will happen over and over again during the entire duration of the game. And in motion, we have a block here that allows us to change either the position on the x-axis or the position on the y-axis. If I change the position on the y-axis, that means that the rocket will move on the vertical. And what we want it to do is to fall. So I'll decrease the position on the y with -2. So it's a short fall, but it repeats forever, so it will keep on falling. So we see it waited for 10 seconds, then it started to fall. Let's try again. When I click the green flag, it will go to the original position. Let's show the screen. When I start the game, click the green flag, it will reposition and then start spinning and sliding down. So far, so good. But one of the goals of the game is to not let the rocket ship fall. So we'll need an action we can trigger from the keyboard that will push the rocket up. That means we make the spaceship sprite interactive. We'll be able to interact ourselves with the rocket and find a way to push it up. We'll choose pressing the space key as a trigger event. So again, I open the events tab. I'm looking for when space key is pressed. So when we complete this event, something will happen. So what we'll do is to change again the position on the y-axis. We want the rocket ship this time to go up. we choose a motion tab, we'll find again the block, change Y by 40. Let's say we go 40 steps up. And then we just wait for a short while. It's good to add this waiting time so the movement doesn't come too rushed on us. So when we press the space key, the rocket will go up a certain distance. It will wait, and then we'll continue a different sequence of code. Let's see if we can test it already. It starts falling, but once I start pressing the space key, and I press it multiple times, I can push it up. So the purpose of this movement is once to keep the spaceship from falling, and then to find the optimal position to pass through the asteroid belt when the asteroids start gliding towards the left. They will glide all the way from the right to the left. I'll stop working on the rocket ship for now, and I'll move to the asteroid. And now I realize that I did not rename it, so we need to rename this sprite, the one we created. And we need to code to control this asteroid belt. For this, what we are going to do is to use what we call cloning. So we'll create clones of the asteroid belt, alternating the 4 costumes. So let's look at the costumes again. So that choosing randomly any of these costumes will clone the original asteroid shape. The asteroid belt will hide from the screen, and the clones will show. Now, these clones are used to make the asteroid scroll across the screen, so we start at the right side of the screen. This is where we positioned, right at the far right end, the original sprite, original asteroid sprite. And then when the clones appear right in the same position, they will start one by one gliding towards the left side of the screen. Once a clone reaches the left side of the screen, it will be deleted, it will disappear. And then a next clone follows, and the next clone follows. They will all start in this position, which is 0.200 on the x-axis and 0 on the y-axis. And they will end on the left side of the screen in the point -200 on the x-axis and 0 on the y-axis, and that's where the clones will be destroyed. So the gliding movement has to be practically to scroll over, to travel across from the point 200 to the point -200 on the x-axis. Let's code this. We started already, so the first thing we did for the asteroid is to position it to the position where it appears on the screen. But we don't actually want it to appear, so we want to tell it to hide. It goes to that position, but the original sprite hides right away. And what we do next is to create the clones. So in the control category, we have these 3 blocks that work for this cloning method. We choose create clone of myself, and then a forever repeat block will allow us to keep creating clone of myself. We have a choice here between the 2 sprites. We are not going to create a clone of the rocket ship. So right now I'm an asteroid, including the forever loop, and we want a short waiting time before the next clone appears. It's actually going to be longer because we need to leave it time to travel across, scroll across for a while before the new clone is generated. I'm going to link this forever loop to the previous code. And this way, when I click the green flag, the original asteroid belt goes to position, it hides, and then it starts creating clones of itself. It starts cloning itself. and then we have a waiting time of 7.5 seconds between the occurrence of the next clone to the next clone. Now, the next thing we want to do is to tell the clone where to appear on the screen. We want it to appear in the same position where the original sprite appeared. So for that, we are going to choose a trigger event, and in the control category, we go back to those 3 blocks that work for coding the clones. The trigger event will be when I start as a clone, so acting as a clone now. In the motion category, we choose go to the same position, 200 on the x-axis and 0 on the y-axis. And we tell the clone to show. So while the original sprite hides, the clone will show. There is another thing that we want this clone to do, that would be to pick random costumes from the 4 costumes. Let's insert switch costumes here. There are 4 costumes to choose from. We don't want to just choose them one by one, but we want to be a random process of picking a different costume every time it runs the code. In the operators category, the green operators category, there is a block that allows us to pick random. We'll insert it in the block switch costume, and we'll have to modify it a bit because we only have 4 costumes, so it will pick randomly between 1 and 4. And that allows us to tell the clone to change its costume randomly between 1 and 4. We can see now that the clones start appearing. If we wait for 7 seconds, we'll see the next clone. And they keep appearing in the same position. So what we need to do now is to make them glide one by one from the right side of the screen to the left side of the screen. For that, we'll use a block from the motion category. There is a block that goes gliding to a certain position on the x-axis. That's what we need. So let's say it takes 6 seconds to glide. That is the cross time. That's the cross time we talked about before. And that's how long it will take to get to the minus 200 point on the x-axis, minus 200, and 0 on the y-axis, and that will be the left side of the screen. And we can already see the clone start moving. And it takes 6 seconds to each of them to get to the destination. Now we see them accumulating to the left side of the screen. What I mentioned before, one by one as they get to the left side of the screen, they are going to be deleted, the clone destroyed. We generate a clone to the right, it glides across the screen to the left side, and that's where it is destroyed, and then we start as a new clone again. This is why it is called a scrolling game. So in the control category, we go back to the 3 blocks for coding the clones. We choose delete this clone, so now we see we have used all the 3 of them. And we wait to see what happens. I restarted the game, so this time a clone appeared, reaches the end, disappeared, and now we can wait the next one. It takes 7.5 seconds for the next clone to appear and 6 seconds to scroll across to the other side of the screen. We are going to align the blocks. We use these cleanup blocks to keep the blocks aligned. That's a nice way of working. And I think we are ready to start working on the interactions, coding the interactions between the sprites. For now, each of the sprites works independently, but there is no direct interaction between them. So we move back to the rocket ship tab, and this is where we are going to code the interaction. The way the rocket ship interacts with the asteroid belt is that if the spaceship touches a gliding asteroid, the game is over. It stops all. It all stops. For that, we need to implement a conditional loop, if then, that will tell the game that if the spaceship hits the asteroid, then stop all. In the control category, we have these loops, which are conditional loops. We'll choose one, if then. And the way it works is that once we insert a condition in this space, if this condition becomes true, the piece of code, the sequence of code that we include within the if-then block will run. So the code will run if this condition is true. The action will be stop all, and the condition will be if touching asteroid. We have these sensing blocks here that we talked about, and we find what we need here. Touching, here it is. We don't need a mouse pointer, we need to find the asteroid. So if touching the asteroid, we insert it in the conditional block. And this is going to work, but we need to include it in another repeat block this time. So we'll choose a forever repeat block because we want this action to happen during the entire duration of the game. And the one more thing that is necessary is a trigger event. So we add when the green flag is clicked, when the game starts. This block will repeat forever. If touching the asteroid, then stop all, the game is over. This is a good practical example of using sensing blocks in Scratch to create a condition for a control conditional loop. Let's see how the game works now. We'll have several actions happening. I'll try to go through the asteroid belt, waiting for the next clone. And the rocket ship hits the asteroid belt. It all stopped. As you can see, everything froze, everything stopped. However, we do need some sort of signaling that the game is over. We need to send a message to the game and to the player, the game is over. And that's what we are going to do next. We'll tell the game to broadcast a message, game over. In the events category, we find the block broadcast message. We just have to edit the message, and we write here game over, and we will insert it within the conditional block. So if touching asteroid, then broadcast game over and stop all, and the rest of the game will receive the message over. We can go to the asteroid tab, and we are going to choose when I receive game over. Hide. We want all the sprites to disappear once the game is over. Actually, we have to do the same for the rocket ship. When I receive game over, hide. This will make all the sprites hide once the asteroid is hit. Let's test it. Right, so everything disappears. We are still missing something. We would like a message, a printed message, a text to appear on the screen saying game over. You know, the big red text message is a game over. So that's what we are going to do next. I'm going to create a new sprite for that. So we choose again the paintbrush, and it's going to be just a text one. We insert the text game over, and we'll resize it to make it like really big across the screen. We center the name. We want to make it red, the bright red message saying game over. Here it goes. Of course, it would be nicer to spend time of it and make it look pixelated, But for now, this text will do just fine. I'm going to save it. And we start coding it like any other sprite in its coding. First of all, we are going to rename it here, game over. And we need to make it show on the screen. So the event now will be when I receive game over, show. While the other sprites hide to receive the message game over, this sprite is going to show. We need to tell it where to show. As you can see, it's not really well positioned. So I'm going to choose, go to the center of the screen. And we need to tell it when to hide as well. So it appears on the screen when the game is over, but we want it to disappear from the screen when we click green flag again and the game restarts. We don't want to start a game with a game over on the screen. That wouldn't look very nice. So when the green flag is clicked, hide. Let's see the game again. Click the green flag. Game over. That's it. And it is very well positioned in the center of the screen. A nice thing to do now is to add a few sounds to the game. We already thought of a few sounds that we found in the library. I'll move to rocket ship sounds, and we'll start uploading a few sounds from their library. Actually, choose from their library. One of them is connect. Let's see where we find it. Right here. This is a nice sound for showing the rocket being pushed up when we press the space key. Then the next one will be coin. This is very good for marking when the points are gained. We didn't implement the score yet, so we'll only use it when we have a score as well. Or to show when we successfully pass through the asteroid belt, which will actually be the action that triggers gaining points as well. The next sound will be the one that shows that we hit the asteroid belt. That will be oops. That is kind of a fail sound, so it's appropriate for when we hit straight. And one more that is called lose. That's for ending the game, but it's kind of a cheerful sound, so it's a nice way to end the game. That's the one. Now we have to code the sounds. 3 of them I'll include in the rocket ship tab. Let's start with connect. So we said that we are going to use connect to show when the spaceship is being pushed up. So first of all, I'm going to the sounds category. We find start sound and we'll include it under when space key pressed. And then we choose the next sound will be lose. Actually, let's start with oops first. Play sound until done. This will play in the if loop, if touching asteroid, to show that we hit the asteroid after broadcasting game over. This sound will play until done, which means that the game will stop only after this sound is finished. The first one will be oops. And then we lose again, which will be practically the sound of the end of the game. And this one will be actually connect. The sounds for showing the rocket jumping up. We have one more sound to implement for the asteroid to show when we succeeded to pass through the asteroid belt successfully. So the asteroid succeeded to glide across to the left side of the game. So the gliding right to the end is complete. So that will be included after glide for 6 seconds to the point -200 and 0. We need to find the sound. So again, we need coin. Then we go to the sounds and we have just a start coin. Right here. We implemented all the sounds, so it's time we see the game again, just briefly. That works well. Let's see what happens now if an asteroid hits me. Fine, so we heard all the 4 sounds. At this point, we finished the game in the simple form, and we are ready to start adding some extensions. The first 2 extensions I'm thinking to choose are the score and the timer, the stopwatch. Both of them are a good opportunity to demonstrate the variables, how we work with variables. We can see there is a category here. So you can make a variable, name it, set it in the game, then change it, show and hide. As the Scratch Ed people at Harvard Graduate School of Education say, the games are a way to make the usefulness of variables more concrete. And that's very, very true. We can actually understand how they work. If you have trouble with the variable and data in school, you know, Scratch is a very good point to start because soon enough it will all make sense. For implementing the score in the game, we make a variable and we name it score for all sprites. You can see it here. We set the variable to 0 when we start the game, so we need an event when the green flag is clicked. And they are also going to show the variable, so it's going to be score. We'll also show the variable as soon as the green flag is clicked. The next thing to do will be to change the variable score by 1, which means to add 1 point. And that will be after the gliding is completed. So when one clone reaches the left side of the screen and the scrolling over is completed, that also means that we succeeded to go through the belt safely. That means we earned a point every time the spaceship goes through the asteroid belt safely. We have to remember to always change the name of the variable. You have to check every time that you did not forget to change the name in any of these blocks. It's very important. Now let's save and see the score in action. Okay, we have 1 point. Every time the gliding cycle is complete, and we survived. Okay, let's wait for 1 more. For the stopwatch, we make a new variable. We name it stopwatch. We are going to make it show right here. And we'll then have to implement something new. In the sensing category, we have timer and reset timer, the timer block. We want to reset the timer every time we start the game. So when we click the flag, reset the timer, we want it to go back from the beginning. Then set the value of the stopwatch to 0. And then we need one control loop, one forever repeat loop to set the timer to attribute the value to the stopwatch to the value of the timer. So we start with resetting the timer, then the value of the stopwatch will be 0 to start with, and then we'll have a repeat loop that will keep on attributing the value of the current timer, the current time, to the stopwatch. We do have a problem, as you can see here. It doesn't look very nice, so we need to round up this number. So of course we'll find something valuable in the operators category. We find round here. So instead of including the timer as it is, we round up, and then the round of the value of the timer, we insert it in the variable set stopwatch too. We don't want the timer to show up on the screen anymore in this form. It's unnecessary since we have the stopwatch. So we are going to go back to sensing and deselect the timer right here so it doesn't appear anymore. In the current form, we can see both score and the stopwatch, the way they function. The stopwatch is telling me how many seconds I survive. I survived for 16 seconds and I scored 2 points. In these forms of the game works pretty well. This is a simple form of the game, so we include only 2 extensions. It is functional, it demonstrates the game mechanics, it can go really far. And this will be the end of the part 1 of the video today, of this demonstration. And there will be a part 2 for adding the levels of the game and subtitles. The subtitles again will be based on a variable and will simulate getting those messages from the assistant, Iris assistant. There will be a part 3 of the video focused on creating the menu with the start button or the start key and a restart, which again can be based either on a button or on a key. So this will be the practical demonstration today. It becomes more interesting when we navigate from one level to another. But it is very important to see how it works in a simple form to just demonstrate the basic functionality of the game. I would like to go through a short review of the computational thinking and computational concepts, the way they were defined by the Scratch team at Harvard University and MIT. Here are the definitions they provided, and you will recognize them now from your practical experience in Scratch coding. The sequence, identifying a series of steps for a task. The loops, running the same sequence multiple times. Parallelism, making things happen at the same time. So you could see that we could run different scripts and different sequences of code in the same time, in parallel. Events, those are the things that cause another thing to happen. One thing triggers another thing to happen. Conditionals, making decisions based on conditions. Operators, support for mathematical and logical expressions. And data for storing, retrieving, and updating values. And at this point, I'm sure they do not sound very complicated anymore. They don't sound so abstract anymore because you use some hands-on experience in Scratch. And this is exactly the purpose of Scratch, to allow us to understand these computational concepts in a practical way by just implementing them in games and having fun. These are the website addresses of Harvard Educational Team. CT means computational thinking, where they provide the definitions and a lot more information about how they understand these concepts. Just to finish, I would like to remind you the 6 rules of Scratch. Be respectful, be constructive, share, keep personal information private, help keep the site friendly, and have a lot of fun. Just explore, experiment, and learn as you go. And if you liked the session today, my teacher account again is teacher Adina. You will not find it in the normal Scratch system. It is on a different system, which is only for teachers. It is a teaching system. But you can find it on the link provided below. That's where my online classes are. And again, my assistant teacher is my son, George, who's 12 years old now. I work together with my son, a very dedicated programmer and game developer, and we work very, very well as a team. Thank you for attending this session, and I hope you liked it.